Architectural drawings are communication tools. They are carriers of information for all phases of a design project. However, it is important that they contain the right amount of information. Too little and the drawing is useless, but too much and the information becomes illegible. This information needs to be appropriate to the scale. There are several types of commonly used architectural scales shown in this list. This list also shows the main types of drawing to which these scales could be applied. It's very unusual for a scale drawing to deviate from using one of these set scales, and ideally you should always aim to use these standards. For example, a 1 to 200 for a site plan. Avoid working to any scale outside of these parameters. For example, a 1 to 12 scale is also a widely used scale, but it is mainly for railway modelling. A 1 to 285 is popular with US military. Never use made-up scales, scales like 1 to 48.5 for example. 1 to 10, shown here in a scale ruler, is pronounced 1 to 10, and it means that for each unit that is measured on the drawing, the 1, the real world size is at 10 times larger than it appears in the drawing. The following slides show examples of scale running through the levels of required information. From a Nolly map, which considers urban density and population flow, through design scales, scales which you will mostly be working in, and they allow flexibility in designing, looking at the existing and proposed, leading through to a 1 to 2, most often used for final detailing or for specific engineered parts. Unusually, these architects also work in 1 to 1 in order to help collaborators and clients visualize their designs. These different scales require different amounts of detail. You simply cannot see the same detail in a building at 1 to 1000 that you could see as if it were closer to you at 1 to 200. Shown here in this competition-winning drawing, you can see the level of detail required at 1 to 50. But you can also see where more specific detail is required. The designer drew a detail at a larger scale of 1 to 10. It is okay to put different scales in the same drawing, as long as you show what scales they are. Just as an aside, working with scale links directly to the size of paper you are drawing on. It will be very useful and important for you as you continue, both in analogue and in digital drawing, to learn the sizes of ISO standard pages. You may notice in all architectural drawings the scale is always given in context. The previous drawing, for example, was 1 to 50 at A3. This information is vital if you draw digitally and wish others to print your drawings to work from. How you draw your lines also reflects the scale and level of detail in the drawing. Technical drawings are only useful if they are clearly understandable, and that is why it's so important that you use varying line weights in your drawings. To begin, you will focus on using 3 different line thicknesses: the cut-through line, which will be a thick line, any other line, which will be a medium line, apart from dimensions or axes and annotations, which will be thin. You must make sure that the differences in these thicknesses are clearly recognisable. These changes in line thickness reflect the natural way that objects fade as they go further into the distance. Line weights can be used to express depth in the drawing, how far back something is, which you can see in the line weight 2 here. It shows whether something sits behind something else or is even completely hidden by something, line weight 5 here. The weight you give a line expresses whether it is the outline of something, again line 2 in this drawing, or whether it is the surface texture of something, as shown in line 3. Textures and materials are also expressed using lines in the form of hatchings. Hatchings are an important part in technical drawing and are used to show the difference between applied materials. 2 important points to remember about hatching is that they only should be used to show cut-through elements of a drawing. In a project, the same hatching pattern must be used for a particular material in every single drawing in that project, whether it is plans, sections or details. Hatching has a lot of value in communicating these materials and structural details in both sketching and in final digital drawings, and is able to communicate very complex detail and information. When applying hatching, please consult something like the Architect's Pocket Guide or other architectural drawing aids or drafting books. It's important to remember that hatching is a language and not a made-up pattern. Scale dictates how we use hatching as a drawing, and it affects the level of detail we can draw and the line weights we can use. These drawings show how you will have to adapt different hatching patterns in different scales for the language of drawing to make sense. To recap, in using architectural drawing as a language, it is important to consider three main aspects, without which your drawing may not be understood. You need to consider the appropriate level of detail for the scale you're drawing and what you are trying to explain. You need to vary the line weights of the drawing to explain what each line represents and when you show cut-through elements or sections as they are known. You need to use patterns known as hatches to help someone looking at the drawing understand which parts are solid or hollow and what the various elements are made of. When you start drawing at scale, ask yourself these questions to be sure you are following the right path. There is a lot of stuff here to take in, but try not to worry, you are not alone. We will recommend any of these books to help with drawing throughout your career, and they will be very useful in the coming years.